Welcome to Expert Agencies Center for Research and Excellency in the field of power system and power electronics. In today's lecture, we will deal with the Firefly algorithm and its application for a power system problem. First of all, this Firefly algorithm it was developed in the year 2008 by the scientist named Yang. So this algorithm can be used for number of real life applications where it is necessary to do optimization. And many researchers have worked using this Firefly algorithms to solve their optimization problem. For example, the traveling salesman problem, that was also solved using this algorithm. And again, many modified Firefly algorithms have been proposed that can be found in literatures during the year 2018 and 2020. During these durations, a number of updated version of the Firefly algorithms can be seen in the literature. So in this research, we have planned to solve the economic dispatch problem as applied for a 6-unit system. In general, any optimization algorithm can be used to solve the economic dispatch. In this project, we are trying to apply the biological inspired meta heuristic algorithm called Firefly, and the final results from this Firefly algorithm can be compared with other optimization techniques. So thereby you can show that the Firefly algorithm is able to optimize the given objective function. So any general optimization problem will take the form the function f of x. It will have variables f1 comma f2 of x up to fn of x, and we do have this problem subjected to the constraints g1 of x greater than or equal to 0, or we may have some other constraint g2 of x which is less than or equal to 0. So like this, you may have one or two constraints. So here the problem is to find the x vector. So x vector, that is consisting of x1 comma x2 up to xn. So this x vector, which will minimize the main objective function, that needs to be found. Sometimes the objective function may be a multi-objective problem. Maybe multi-objective in nature, wherein you will have, for example, for this case, you will have two objectives. One is the economic operation, economic dispatch, with the emission norms. Or you need to consider emission also into account. At this stage, I am sure that researchers will remember the actual function, that is f of x. F of x is the function to be minimized. Minimize f of x. So here f of x happens to be the summation of I is equal to 1 to n. So n represents the total number of generators. So that is actually Ci into Pgi. Again, so the cost equation will be in the format of Ai plus Bi plus Pgi plus Ci Pgi square. So it goes without saying here, this Ai comma Bi comma Ci, these are the cost coefficients. So the power system optimization problem is to find Pgi, that is the output power of the generator. Power of the generator. So for which power output settings you get the minimum cost, that we need to work out. In this project, we will use the unit as dollars per hour. Again, some researchers do prefer to use the same thing can be converted into rupees per hour also. So recent papers published by Indian authors, they do present the results in rupees per hour. And one notable difference in this problem compared to the conventional economic dispatch is the addition of emission in the objective. So emission will take into account mainly these things. One is the NOx, then SOx and CO2 impacts. So I am not going to explain you deep the effect of emissions because that is beyond the scope of this research. If students want to obtain training plus the Matlab coding for economic dispatch using nature inspired algorithms like the Firefly or other nature inspired algorithms like gravitational search or artificial bee colony, they can very well contact our institute through email or in the given WhatsApp number. Thereby they can take assistance as well as training in completing their research related to power systems. The next part of this video or the next session will be related to the Matlab program used to simulate the Firefly algorithm as applied for the economic dispatch problem. And at this stage I would like to give you some hints related to the formulas used in the coding. Inside economic dispatch solved by Firefly, you will have one parameter called attractiveness. So it is beyond the scope of this small presentation, but anyway, researchers working in this area should be familiar with these terms. Inside the Firefly code, you have a term called attractiveness, and in that the main variable is R, that is the distance between any two flies, and one more variable is beta naught, that is the initial attractiveness, and you will have one more thing called lambda, that is called the absorption coefficient, which controls the decrease in light intensity. So only precise ideas I am giving. So further you can refer some literature material. What is the formula for attractiveness, that you can get from the literature materials. And one more parameter is the distance. So generally it is defined as the Cartesian or Euclidean distance, and the main thing for distance is depending upon the number of dimensions, the formula will slightly vary. And one more parameter is the movement. The movement of Firefly here you should remember that if the brightness is more, the Firefly will be more attracted. So again here you will have a coefficient called alpha, so that should be set in the region of 0 to 1, and I will go to the actual Matlab simulation wherein we solve the economic dispatch with Firefly. So theoretical aspects, users can have a tutorial session with our professors. So there if you want additional training, we can provide you about the algorithms, mathematical part, those things we can have a private discussion if needed. So next part I will go to the simulation part.